Is recording on progress? Looks like it is. Okay. Please scan the QR code to mark your attendance. I'm not sure if anyone is going to be online. It's okay. Have anyone not scanned the QR code? No? Okay. So, welcome to the Unity workshop. Thank you for coming down. I know it's quite a late night session. Yeah. So our club sessions will usually be physical at this time. There were some logistics issues in the previous 2 weeks, which is why we had to do it online. But that's not a huge problem. Okay. So we're gonna look back at what we learned what we're gonna be learning today. The first one would be instantiating objects, and the second one would be animations. So instantiating is not going to be very difficult. Animations, on the other hand, will probably take you some time. So I'll try to go through a bit slower since it's physical, and I think it's better if you guys can follow along. Yeah. We see. Okay, cool. So this is what we had in the previous weeks. This is what we had in the previous weeks. Don't mind that the license of this is in Korean. Okay. Can the people at the back hear me okay? This volume is okay? Okay, cool. So if we check what we did in the previous week, we had a moving player, we had a spike that kills you, and if you jump on top of the enemy, you can kill it, and it gives you points. Turn the scale down a bit. Yeah. So basically now, the game feels quite complete already. You have a very basic mechanic. You have a very basic gameplay cycle, and all that you do now would be try to polish this, which is what we'll be going through in this week's and next week's workshop. Okay. So what is instantiating objects? Instantiating objects essentially means that you create or clone a new game object of a given type, usually a prefab, during runtime. So when the game is running, you spawn this object out of thin air, so that it appears. In certain games, you probably would have seen it as well. For example, if you have played FPS games, you would see like ammo packs spawning randomly or spawning in fixed intervals after they are picked up. So these are usually done with instantiating. Yes. So these are usually done with instantiating. If you play things like Super Mario, for example, if you play Super Mario, you jump on like a question mark block. Sometimes coins fall out. Sometimes mushrooms falls out. These are also probably done with instantiating. Loading, unloading. No, those are not done with instantiating. Loading, unloading is a bit more. It's a bit different than instantiating. Yeah. You don't usually do that in 2D, right? Okay, it's fine. So basically, that is what instantiating is. You try to spawn new instance of a particular game object during runtime. And the objects that you create have the exact same template data, which includes all the components, all the properties of the components. If you attach a script to it, it will have all the same values as well. So it just feels like a clone of the template. So let's look back into our game, and where can we start making this instantiating thing, right? Is that what if when our enemies die, they drop a coin? Yes. What if when our enemies die, they drop a coin that we can pick up? So they'll be able to kill the enemy, get points, and then it drops a coin, and they can pick up the coin to get points as well. So that is the expectation. So what we can do is we go back to the scripts that we did. And over in enemy movement, we're going to open this up very, very quickly. Takes a while. Okay. So we open this up, and we've went through several Unity-based events already. We have start, which is called when the before the first frame of this game object being instantiated. We have update, which is called every frame. And we also have on collision enter 2D, which is called when there is some kind of collision when it collides into a different object. It's on collision enter 2D. In play interaction, we also gone through on trigger enter 2D, which is when the trigger collider has some form of other colliders going into it, so that it's being triggered. So here in enemy movement, we will also want to use one of the Unity built-in events to have this behavior in which the enemy dies and then it spawns a coin. So what we can do is to use this onDestroy function, which basically when the object in which this script is attached to is destroyed, this method will call. This method will be invoked. So for now, we're gonna put just debug log enemy killed so that we can see that this is working properly. Takes a while to reload. Okay. Let's play this. Shit. Enemy killed. Okay, so this means it's working. So now I want this to spawn a coin. And before we instantiate it, we need to give this a template, which is a game object in which that it could clone from. This is what we call a template, and it's usually a prefab. So here, we're going to add a public game object reference. And I'm just going to call it a coin prefab. Once I'm done with that, I can go back to the game, to the editor, and in the enemy here, when I scroll down, I will see that coin prefab shows up, and it shows up as a game object. It says none. If I click on it, I will be able to select any object in the scene. But that is not what we want to do. What we want is to put in this gold coin to this enemy movement script. And now you notice that there's a blue line here. If you've come to last week's workshop, you should know what this blue line signifies. Any guesses? You guys see the blue line? It's here, it's here. Any guesses? Okay, a prefab is something specific to a prefab. Anything else? Any other guesses? prefab is assigned to a component. Not quite, not quite. Okay, so basically what this blue vertical line means right next to this property is that the prefab property of this component is modified. It's an instance of the prefab that is being modified. So if I were to drag in another enemy, right, and I look at this, you will see that the coin prefab is actually not here. Because what we have modified is an instance of a prefab and not a prefab itself. But that's okay. In Unity, you'll be able to apply the changes that you have modified to an instance of a prefab back to the prefab itself. And you just need to scroll all the way up and click on override and click apply all. By doing this, it's going to assign all the properties that you modified for this instance of a prefab and propagate it back to the original prefab. So now if I pull this enemy into the scene, you will see that the gold coin prefab is applied. So there are several restrictions to this. The first one is that the values that can be overridden in this way must either be also a prefab or it must be a primitive value. It must be something that cannot be changed. It's not like instance specific. And since prefab kind of feels like a class, it's a template of all the instances of object, you'll be able to assign to this without any issues. Someone is joining. Okay, cool. So now that we have assigned this coin prefab, we still need to instantiate it. So when the enemy is killed, I'm going to write this line of code, instantiate coin prefab. And we are going to instantiate it on the exact location where the enemy died, which will be transform.position, the current position of the enemy. And then we also need to supply this quaternion rotation. So quaternion is a specific class to Unity which acts like a third axis for rotation purposes only. You probably don't need to know too much about it for now. Just know that if you want to instantiate something without a rotation, you would supply quaternion.identity. This will give this a rotation value of 0, 0, 0. Someone joining. Cool. Okay, so after this line of code, you will see that this should work properly. You can see that the coin spawned there. Okay, let's try again. And then we can pick it up, and the behavior of it is exactly the same. Right. Yes. So yes, this is instantiating. Yeah. Yeah. Okay. Any questions? Yes. Drag in an instance of the prefab. You need to drag in the prefab itself. Okay, I think a lot of people didn't catch it. So in order to drag it in properly, you need to go to your projects folder here. Click on the coin, go to enemy, and then drag on the coin in this here. Okay, I cannot like this to assign it properly. Let me see if I can get the mouse highlight for you guys. Give me a moment. Wait, where is it? Mouse utilities. Mouse highlighter, Win Shift H. Yes. Always highlight yellow. Okay, is it better to follow like this with the highlight? I go with this. So you would drag this gold prefab in the prefab folder and put it inside of the enemy movement script. Only then you will be able to assign it properly and then put it into the enemy prefab. Okay, any questions? Any problems? So far so good? Yes. Okay. I also zoom this in.
Actually still secretly kind of 3D because
Okay.
I see a lot of the application they mentioned C, then they were also confirmed.
Yes. All the 2D engine in Unity is actually the squashed version of the 3D engine.
I knew it.
It's the opposite for Godot. Godot started off as a 2D engine, so the 3D engine is just the 2D engine plus the z-axis. Unity started off as a 3D engine, and they just squashed the z-axis.
But so for 2D, is it possible to like have built like 3D-ish depth? From 2D?
If you would say from vanilla, no. But you can make use of video effects to build this 3D depth feeling to it. For example, add a background that feels like there's fog of war. Use parallax animations so that it feels like there's something going on in the background. Yes, question. Oh, you need to drag the goal from the prefab.
So basically the Z-axis is just there for sure.
Yes, it's just there for sure. It's a bit of use because it's a bit more to the graphics side of things. So I don't think it's very important, but you can think of it as just for show.
Yes.
Okay, I guess everyone followed through. That's good. So now we can move into the actual topic of the day, which is animations. Okay, so the animations in Unity is separated into two parts. The first part is an animation. Specifically, we would refer it to the keyframes of the animation. So what are keyframes? Anyone here has any guesses?
Oh, basically the most important frames, like it's kind of like the pieces of the storyboard.
Okay, the most important frames, yes.
Store the position and rotation.
Position rotation, not quite. That's not what a keyframe is for. At least not in the sense of an animation.
Basically, it's kind of like postmarks with inside, but basically, like how did I explain this? It's hard to understand.
Okay, so a keyframe essentially is the frame you want to put into your animation. We kind of think about animations as just a continuous stream of pictures. If you have watched anyone on YouTube with those kinds of flip cards, animations kind of thing, yes? Basically, every single paper that they scroll through is one image. Every image is a keyframe. When you combine all of these images together, they form a fluent animation. They form very fluent animations between every single image so that it looks like it's a video. But in essence, it's just a bunch of images together in a stream. So to put it into perspective, remember this our asset pack? In this sprites folder, you can look at our player. There's idle 0, and then idle 1. So if you take a very close look to this image here, right? If I quickly go back and forth, it looks like there's animation for this image, even though it's just 2 images. So this is what a keyframe is the images that have changes that will give you the illusion that it's actually one single contiguous motion. So essentially every single 2D game, okay, in the context of a 2D game, your keyframes are just different sprites, different images. In a 3D game, yes, your keyframe would store every joints, position, rotation, all those kinds of things. But in a 2D perspective, it's just images. It's just a bunch of sprites that have differences between each other, minor differences between each other, such that it feels like it's actually one continuous motion. So that's animation. And different things such as the sprite changes according to the keyframe. So as I've shown just now, because it's just a bunch of images, we display these changes in the image in the game itself. So the sprite actually changes so that it shows up as a contiguous animation. And the animation ends, quote unquote, ends when all the keyframe has been visited once. So think of it, you put keyframes into different parts of the timeline in a very straight timeline. And once all the keyframes have been visited, it ends. So the animation ends, but you can loop it. This means you will be able to keep on repeating this same animation over and over again without needing to infinitely extend the number of keyframes that you add. And finally, the advanced part of animations is that you can use these keyframes or use the timeline to trigger certain events. But we won't be going through this today. The second part of animation is an animator. So an animator stores all the animations, all the animation clips, all the animations for a specific game object. It handles transitions to different animations, and internally it is being implemented as a finite state machine. I don't think this is very important as well, but it's good to know. I'll show you guys what it looks like later. You can impose conditions between each transition such that certain transition to certain animation for this game object will only occur when a condition has been fulfilled. For example, say you want an animation, you want the player to have an idle animation. It stands still, okay? When the player moves, you want it to show a walking animation. So how do we know that a player is moving? Is when the player's velocity is not equal to 0. So once we know that the player's velocity is not equal to 0, we will be able to transition the player from the idle animation to the walking animation. And back, vice versa. So you can impose these conditions onto each transition such that it looks more logical. And finally, you can change the time required for each transition, which is not really important unless you're trying to polish your game to the finest, such that every animation feels like they are very seamlessly connected to each other. Okay, let's show you how it's done. It's probably not going to take very long. So this can be done almost completely in the editor itself. So first, you want to go to Window, and then go to Animation, and select the Animation pane, which opens up this. Then you want to go into Window, Animation, and open the Animator pane, which should likely open this up. Okay, let me shrink this a bit so it's easier to work with. Then you need the assets to be an animation or an animator. So I'm going to right click and create a new folder called Animations. And let's create multiple folders such that you can also work with the different animations of different game objects in the asset pack. Let's make the player folder first. I'm gonna open this up and create an animation, which I'm going to just call this player idle. When you have an animation, you need to attach it to an animator. I'm going to right click this and then select animator controller. And then I'm gonna name it player anim controller. So the player anim controller will open up this animator pane, while the player idle is not gonna have anything. It will show up as this player idle thing in the animation pane. Not sure if I could zoom this in, but yeah. So what you're gonna do is that you want to go to your player game object and attach the animator to it by dragging and dropping, and this should show up as a controller, animator controller here. And once you're done with that, is everyone following okay? Okay. So you select player, and then you're gonna click on the you're gonna drag and drop this animator into the player. You right click, create animator controller. It should be at the very bottom here. Oh, you need to drag it to the add component thing. So okay, let me remove this. So you drag it to the add component button, it's gonna add it. Okay? Okay, so the thing about an animation is that you will not be able to preview or edit an animation until it is assigned to a controller. So we have the controller already. Now we need to assign the animation to a controller. And in order to do that, you just need to drag the animation, which is this triangle, into the animator pane. And this will open up this new player idle orange box in the animator. Like this. So you just drag this in and this will open it up. It's animator. You need to open window, animation, animator. It's okay? below. There is an animation. You create an animation here. Are we good? Are we good? Okay, can I move on? Yes, maybe. Okay, I'll move on. So once you have this player idle box here, you can move it around and you will notice that it actually has an arrow from entry. It has an arrow from this entry box. So the entry box is the box in which the animation starts. So every animation starts from entry and is going to, by default, go straight into the animation that it is connected to, which in this case, it will be player idle, which is why it's highlighted in orange. This means that this is the default state of this animation, of this animator. Yeah, the default state of this animator. So once you've added this, you can select the player. With the animation pane open, you'll notice that it lights up, and now there is an add property button. So once this lights up, we will be able to edit this animation clip. We're just gonna go to sprites and then add in idle 0 by dragging this into the animation pane and add idle 1. You can add them side by side or move them apart. I'm just gonna move it to 0.10 apart of each other. And we are we okay? Let me see. I do one. It should be in your asset pack. No? Or you need to select the player.
I selected front one, left one, left one. Oh.
Okay, are we cool? Everyone following. Okay, so once we're done with this, we can go back to our animator. Okay. And as I press play now, you should see the player move very quickly once. Okay, you can probably not see this. Let me zoom this in. Take a very close look. It's gonna move once.
Oh.
Okay, so this is because the animation ends when the keyframe ends, as I mentioned. So there's only 2 frames in the animation, which is idle 0 and idle 1. There are 0.10, which I believe is 1/10 of a second.
Yes.
Yeah, it's 1/10 of a second apart from each other. So it's just gonna go 1/10 of a second to the second image and finish. So we need to loop this. So before we loop, we need to understand that how the animator actually plays your keyframe. Yes.
It's 1/10 of seconds.
Yeah, it's 1/10 of a second.
It's up to 60.
You can go beyond that.
I mean, when it's go to 0, 0 and 60 become 1.
Yeah. So it kind of scales upon that. But if you are in this scale, the default scale is 1/10 of a second. Okay. So we kind of need to know how this animation clip is being played. Essentially, when you press play, you will see that this thing goes all the way here and then all the way back. And then it goes again and then back and goes again and back. So this means what this is going to be is that the moment it reaches this second keyframe, it immediately resets. So even if we loop it as is, it's not going to have a smooth animation. You're just gonna see two images suddenly twitch together, and then it's just gonna be a very fast flicker. So let me show you what it means. So in order to loop this, I need to go back to our animations and select the animation clip and click on loop time. So this will loop the animation. And if I press play here, you will see that it is looped. But it feels like it's going through a seizure or something. Okay. So as I mentioned, that's because our animation just plays up until here and then teleport all the way back to the first frame. So in order to solve this, we just need to smoothen this out by adding the first frame as the last frame and then space it evenly apart. So I'm just gonna open back the animation pane here, go to our sprites and drag in idle 0 to 0.20. So now the animation is going to play like this, which you'll be able to preview this. And this is much better. Give me a moment. Yeah, okay. So yes, this is exactly how you would add animations. But obviously having just one animation is not enough. So we will try to put all the animations of the player into the game. So I'm gonna right click create and we're going to add a new animation, which is player run. And then we're gonna create another one, which is player jump. So run and jump, which we also have keyframes for all of this. Okay, so again, we are gonna go into the animator pane and put player jump and player run into the animator. Then I can go to player and start adding these animations in. So you'll be able to switch between the different animation clips by clicking on this player idle button here, which shows you the different clips that exist on this animator. So I'm gonna select player jump, which should contain the same thing. Let me go to sprites, and I'm just gonna add jump 0 and jump 1 here. Let's put this like this. And this should also come up here. Yes, you can put it there. That's what we're going to be covering later. So I'm done with jump. Now we can do run, which has these 4 keyframes. I'm going to add them in manually, like this. It's 1/10 apart, and put run 0 at the very end. Good. Are we following? Okay. Yes. Good. Good. So now, we also need a run to loop, but we do not need a jump to loop, because the jump would be a one-time animation every time you jump. The legs are not supposed to flap when you jump, I guess. So once we're done with this, you'll notice that there is no way for us to trigger these different animations properly. No matter what you do, your player is just gonna stay in the idle animation. And this is because we need to specify under which condition that these animations will be triggered. So let's specify that we want to be able to go from idle to run like this. And the way you do it is by right-clicking one block and then click on Make Transition. And this will spawn this white arrow for you. And by clicking on the other blocks, one of the other blocks, this creates a transition. And you can do it the other way as well. We want run to be able to go, we want to be able to go from the idle animation to the run animation, and from the run animation back to the idle animation. Is that okay? Feels like a two-way transition there. If I stop from running, I want to go back to idle. If I start running, I want to go to run. So let's just do this one transition first. So you'll be able to select on these arrows by clicking on it. And this brings up this transition inspector, which here you will be able to add a list of conditions in which this transition will be triggered. So as the condition is fulfilled, this transition will be triggered and the animation will go from idle to run or back to idle, vice versa. So in order to do this, we first need to specify a few parameters that can be used as a transition. So I'm going to go into the animator and select the parameters tab and click on add, and we're going to add a float. This is going to be the speed. So if the speed is greater than 0, we want to start running. This means the player is moving. Else, I will stop. This means the player stopped. The player stopped moving. Does that make sense? Yes? Okay. So in conditions, I'm going to click on add, and you will see speed being selected already. So I'm gonna say if speed is greater than 0, the transition will go from idle to run. As you can see here, idle to run. As my speed is greater than 0. Okay. And I want to transition back to idle as my speed is less than 0.01. So if I'm less than 0.01, which means I'm close to stopping, I will transition back to the player idle animation. If I start moving, which is when my speed is greater than 0, I will move into the player run animation. Is that clear? Clear? Yes? Okay. Good. So now that we have this, we need ways to specify that. We need ways to specify this value to the animator, because the animator doesn't know what speed is. It's just a random name that we've given it. You see, it still doesn't work. And how do we specify it? At this point, you would have already figured that we have to write code. So in the player movement script, I'm just going to do this very rudimentary. I'm going to have a private animator. I'm just going to have a private animator reference, which is called animator. Okay. Then in start, I will assign this to a get component animator. Okay. Okay. Good. Everyone following? Yes. Okay. So once I got this animator here, on every frame update, yes. There's multiple. Okay, you should only attach one animator to a single game object at the same time. Okay, this animator I get, right, is this thing. It's not the animation clip. It's a different thing. As I mentioned, it's separated into two parts. The animator is what controls the transition and the conditions of the transition of different animation clips. Okay? So once I get the animator, here, every frame, I'm going to assign the speed value to the animator. We can do so by using the setFloat function. And since I named it speed, it's case sensitive. Since I named it speed with a capital S, this is the float parameter that I'm setting. And I'll set it to our velocity.x. So every frame, this float changes based on whether or not I have moved, which is my x component. Okay. So let's try this out. Then click on play. And as I move, you'll see that, okay, maybe I should just remove the spike. No. Okay, the enemy will still run into me, right? I should just make this longer. It's my tile map. And where's my tile palette? Okay, let me just make this extremely scuffed. It's okay. This is a workshop game after all. Okay, this is good. So I'm gonna click on play. And let's move. Okay, maybe I lower my speed also. You can see that I am moving. But why is it that when I move to the left, it doesn't move?
It's only positive and the other one is negative.
Yes, so velocity has direction. Negative means left, positive means right. So in order to do it properly, I need to use a absolute here. Okay, it's math f dot abs. So as I supply this as an absolute value function, this means that it will always be positive, and that as soon as it moves, it will be below, it will be above 0. Okay, so let me just change the player speed a bit so that I will be able to demo this properly. So let's look at this. Looks good, right? Okay. Now the second transition, which is jumping. Okay. So we need to be able to jump. And since we can jump when we are either in idle or when we are running, correct? We can jump just by not moving as well. So here I'm gonna just connect this from any state. This means the jump can be triggered from the jump animation can be transitioned from any state of the animator. And from jump, I will transition to idle. And that's it. Okay, let's not touch anything else. This is good enough. So I go to this any state transition here. It says any state to play a jump. There is a condition. We need a condition. As it tells you here, transition needs to be at least one condition. So here I'm gonna click on a trigger. So a trigger is sort of like, I mean, it's just a trigger. So it occurs, this transition will occur when this trigger is called, when this trigger is changed, when this trigger is enabled. And the trigger will automatically disable itself after 1 second. I think it's 1 second. So I'm just gonna call this jump. So as the trigger is triggered, this will jump, and from any state, this transition will be toggled, and then the player jump animation will be called. So I'm gonna go into here, and in the jump function, I'm going to do animator dot set trigger jump. And remember, it's case sensitive. Okay. Is this good? Is this okay? Yes. So as soon as we jump, we set the trigger of jump so that the jump animation shows. Let's show you guys that this is working. I'm just gonna click on play here. I still will be able to move around and it runs. Right. And as I click on jump, wait, give me a moment. But this is not jump. Okay, I forgot to add a condition to the tree. Oops. Okay, so I need to add this condition and select jump. So go to the any state transition and condition, select jump. Add a condition which is jump. So now, hopefully this works. Looks like it's working. Okay. I mean, it looks okay. What was that? Okay. So, question? Any question? Yes. Add jump. So as the jump is triggered, this will be off. So as you can see that the jump animation is working now. It's a bit scuffed, as you can see. So as I jump, right, I will be able to start walking mid-air. Okay, why is this so? This is because a trigger happens and then it immediately exits to idle, and which immediately has the speed which allows it to go into the run animation. So you must think of it as this tree here that you see is stupid. It doesn't know when is when unless you specify a very specific condition for it.
Actually, if your character keeps falling, then you can start doing the run.
No, because the speed that we supply is only the x velocity. So yeah, it will just start moving on its own because we don't supply the entire velocity component. Okay, so because of this, you will have to specify more specific conditions. For example, you would specify that the jump to idle transition here can only happen if we are not jumping. This means we actually fell on the ground. And in order to do that, jump will need to be a Boolean value and not a trigger value. Does that make sense? So as I jump, I change it to be a trigger. And as I jump, I change it to be true so that it transitions to the jump animation. But I won't transition back until we change this jump boolean to false. Okay, so let's do this very quickly to show you how you can do this. So we will right click and delete the old trigger condition. Just delete it, don't care. And then I'm just gonna select boolean instead and name it trigger. Then we go to the any state to player jump condition. Go to the condition and select. Okay, sorry, it should be named jump. Boolean jump. Any state to player jump transition. Select jump, the condition to true, and player jump to player idle transition. We're gonna select jump false. Okay, does that make sense? So this means this transition will trigger as jump is set to true, and this will trigger if we are in jumping animation and jump is set to false. Are we okay? Okay, I'll continue for now. So Now, obviously, we cannot use set trigger anymore. So as we jump, we want to do set boolean or set bool jump to true. Okay. And then checking if we are on the ground every update might be a bit might be a bit expensive. Right. So what we're going to do is that we're going to cache this also in a local Boolean value is grounded. So what we're going to do with is grounded is as we jump, we set is grounded equals true. And if we are not grounded, okay, if we're not grounded, we do is grounded equals not is grounded, equals is grounded, equals the method is grounded. Okay, maybe I changed the name for it. Okay. Oh, we change it to be is jumping, okay? We change this bool to be is jumping. We set is jumping equals true. And if we are jumping, jumping is equals to not grounded. Okay? To iterate the code, we have a private bool is jumping. In jump, we set is jumping to true. And if we are jumping, we set is jumping to equals to not grounded. This means if we are not grounded, we are jumping. If we are grounded, we are not jumping. Okay? Sounds good, sounds good. Everyone still following? Yeah? Okay. Okay. So now that we've done that, we are going to go back into our animation tree, ensuring that everything is correct. And I will press play. So now you should see I will be able to jump. Oh, but it loops like this. This is because I did not set this to false. Okay. So let's make this a bit more explicit. So if we are currently jumping and we are grounded, this means the moment we touch the ground when we are jumping, we set is jumping to false, and we set animator to false. So this is the revamped logic. Okay. So we're gonna move back into here. Select the player. And press on play. Oh no. It's not working properly. Why? Okay, so the reason is because the first frame which we jump, we are grounded.
So which means there's a frame perfect glitch, right?
There's a frame perfect glitch, yes. The first frame in which we jump, we are grounded. So this is immediately set to false. Difficult, difficult.
Why is it disabled? Because the installer is not initialized.
Which one? This one?
I mean,
Okay, so what happens is that we jump, this becomes true.
yeah, I mean before you draw it, it's not initialized.
No, it's always false. The default initialization of Boolean is false. Okay, but it's a C# thing, so we have a frame perfect glitch here. Right, so there are ways to fix this. For example, we can do something like a timer we can do a timer. So within the first 0.1 second after I jump, I am not gonna check whether or not I'm grounded. Okay. So here I'm going to set the timer to its default value. And we're gonna revamp this logic again. So if we are jumping, we say timer, no, the jump timer is reduced by time.delta time. So time.delta time is the time that passed between two frames. So between the frame updates that we get. So this is time.delta time.
Shouldn't we double time everything? If not, I feel like one can change the framework.
That's true if you are working with positions directly. Since we are working with velocity, you don't need to do that. Velocity is already normalized. Okay, so if we are jumping, we do this, and if jump timer is smaller equals to 0, F, and is grounded. We set it to false, and then we set bool jump to false. Okay, now I can't put this in the first frame because usually the frame updates would be 16.7 milliseconds, which is 0.16. I need to put this at the very end. So this means after the first frame, only then we check if we are grounded. You can tweak the value if we can tweak the value if it still doesn't work. But you can see it works. So what is happening here? Why am I still repeating? That's because a jump is also its own state. And since the jump is also part of any state, we can transition from jump to jump, which makes this looping effect. So what we may need to do is to disable this in the settings, can transition to self. This means that jump cannot transition to jump. And now as I press play, you should see that this should work properly. Yes, we disabled can transition to self. Okay. It's not really perfect. Yeah. Yes. So the way to do this is we select the transition and click on has exit time to disable it. This means that the previous animation will no longer have an exit time, which stalls this animation until it finishes. And then only then it can transition to the next stage. Where is it at? Okay, you click on this and go to settings. There's a drop down settings here. And then there's can transition to self at the very end. Do you see it? Okay. And then click on this jump to idle and click on has exit time to disable it. Okay. Okay, so in Unity, transitioning between animation has this property we call exit time. So when we are in this state of this animation, if we want to transition to this other state of this animation, we need to kind of smooth it, or like the developers from Unity thinks we probably need to want to smooth it a bit so that it doesn't just transition over. And this delay in between these transitions when the condition is triggered is called exit time. It's usually like just a split second. But in certain scenarios, we don't want this exit time because it will mess up with the fluent animation that we have. Make sense? Okay. So now as we play again, hopefully we will see this stop jumping as soon as we drop down, which is a lot better, I guess. Looks a lot better. It's about 1 frame off, and is not something we can really tweak. It's a limitation of the engine. You can try to make the transition happen a bit faster. For example, instead of using is grounded, we have a second one which has a much larger value. Yes. So it will be a more near ground or approximately on ground, something like that. Not gonna go into the details today, but as you can see, tweaking the animation is a very tedious work. Yes. So as it's also part of polish, it usually takes up like the final 50% of the development time to do the 20% of the polish that you want to do. Okay, but that's philosophy. I'm not going to go into that. Okay, so the final thing today that I'll be going through, we have quite a bit of time. Okay, now that we have both the player animation done, right? It sort of works properly. We can jump. The transition time is not pixel perfect. That's because we know there's exit time. So all you need to do is to just cancel off the exit time if you want this to be a bit more like interrupting. But that's fine, that's okay. So the final thing to do here is that you will notice that all of our player is facing the same direction. Right. So we move to the left, we are expecting the player to also turn to the left. If we move to the right, we will expect the player to also face towards the right. 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 So that's like the basic model that we should have. So in order to do this, we're gonna once again head back into the code. And here we want to use a different component that is attached to every 2D game object that has a sprite. It's called the sprite renderer. And let's just call it the sprite renderer. Yeah, I'm just going to use the full name here. So we're going to assign sprite renderer. And here we're just also going to do sprite renderer equals get component. Sprite renderer. Okay. So what can we do with this sprite renderer? So in this sprite renderer, we have this property called flip X. There's also flip Y. Can anyone guess literally what it means?
It means flip along the axis.
Yes, so it flips along the axis, but it's not flipping along the X or Y axis. It's flipping
The component.
the component. So flip X means that it's horizontally flipping. And flip Y means that it's vertically flipping. Like this. Okay. I guess let's speak it. I think it's reverse, right? I think if you use if you use Photoshop, this is flip vertically. This is flip horizontally. Or something like that. Okay. But we're gonna use flip X. So flip X is actually a Boolean value. It specifies that whether or not we should flip in what condition. So if we do something very rudimentary, such as flip X equals velocity X smaller than 0. This means that when our velocity is smaller than 0, which means we are going towards the left side of the screen, we want to flip to the left side. At first glance, this looks like it should work properly, right? I mean, your mental model probably says that, yeah. So let's try this. But what you're gonna notice is that it does work properly. But if I'm going left and I stop, I turn right immediately. Why is this? Any guesses? Yeah, your velocity X is back to 0. It's not smaller than 0 anymore. So we can't just make something as rudimentary as this. We need a little bit more code to make this work properly. So similarly to how we did this is grounded thing, this is jumping thing, I'm gonna make a new Boolean called is right or is facing right. Okay, let's make this a bit more descriptive. So what I'm going to do is that since we always start facing right first, in start, I'm going to assign this value to true. The default value for bool in C# is false, which is why jumping is false at start. There's a bit more to the specifics of C#. It's good to know, but you don't need to know that. So we set is facing right to true. And what I'm going to do is add a couple of conditions here. So if we are moving to the right, which is when our horizontal move is greater than 0, and we are not facing right, okay, I will set the sprite renderer flip X equals false. So we don't want to flip when we are going towards the right. So when we're going towards the right and we are not facing right, we flip this to false and we set is facing right equals true. Else if our horizontal move is smaller than 0, okay, and we are facing right, this means we were facing right and now we're moving towards the left side. We are going to flip X and we are going to say we are not facing right. Can everyone see this code except okay? Is this logic clear? So horizontal move is our input, which is A and B. If horizontal move is greater than 0, this means we are moving towards the right side. If not, we are moving towards the left side. So if we are moving towards the right side and we were not facing right, which means we were facing left, we will move towards the right side. And then our sprite renderer is going to not flip, so it moves facing the right orientation. If we were facing right, and now we had an input towards the left, and flip over and start moving. Notice that if I stop here, we were facing left, but because my horizontal move is not greater than 0, I will not flip over. Okay, this is the logic. So let's go back and to demo that I'm not being delusional. Okay, I'm facing right. I move right, no changes. I move left, I go left. The moment I stop, I still stayed facing left. And if I move right again, I move right. And the moment I stop, I'm still facing right. Cool. Cool. Do I still need to show this cool excerpt? This is good. Yes. Cool, cool. Okay, so any questions today? Any questions? No questions. Do I have anything else? Okay. I forgot to change the date. Give me a moment. Sorry. Was it this one? Yeah. What do you mean? What does it mean? So we know that update triggers on every frame update, right? So on every frame, the update function is called. Time.delta time is the time between these frame updates. So if I have a frame 0 when the game starts, I have a frame 0 when the game starts, right? Then eventually it moves to frame 1, frame 2, and on every frame, it calls the update function. Okay. There must be a time in between because your CPU takes time to compute, your GPU takes time to compute to display the image to you. So the time in between these frames is delta time. Okay. So what we do when we minus equals time.delta time here is to figure out this thing here so that it feels like one frame has passed. Because this is generally 16.7 milliseconds, which is 0.0167 seconds. If we are looking at 60 frames per second, which is the default in Unity editor. Make sense? Okay. Yeah. We'll erase this later. Any other questions? No questions? No questions? Check my date. Give me a quick moment. I want to double check something. Okay, yes. Okay. If you don't have any questions, we are sort of done for the day. Okay. But before I end today's session, week 5 game jam. Okay, so this is week 4 already. Next week is week 5. So on next Saturday, which is 14th September this year, we'll be hosting a 10-hour long game jam. You come in, you form your teams, and I will highly recommend you guys to participate. Now that you have gone through the basics, you can find something a bit more challenging to challenge yourself. 10 hours usually is a team of 3 to 6. You can try to find artists, musicians is a bit of a stretch, I would say. But programmers form up together, and the themes will be announced on that day. It's usually some wacky themes that we have. Few semesters ago, there was this theme about what was it? Yes, your controls can only have 2 keys or something like that. Okay, so geometry dash kind of game, you know. Right, so the themes will be announced on that day. You can expect something kind of whack, sort of de-stress yourself. I don't know, maybe you're more stressed. You come over. Okay, but it's a very chill challenge. You come over, you try to refresh your memories about game development. We usually have senior batches join in as well because we also provide dinner. It's usually free pizzas. Okay, we should have enough for everyone. And yeah, so you have learned basically everything that a beginner should know about Unity. Next week, we'll go into how you can integrate with Git and use GitHub to collaborate with other programmers. Anyone here not heard of Git before? Okay, we'll go through that next week. So there will be Git integration and GitHub integration such that you'll be able to work with other programmers to prepare you for game jams. And we'll also go into how you can package, build, and publish your game on itch.io, which is a website for indie games. I would say indie games. So do come next week if you plan on joining Week 5 Game Jam, because a lot of the collaboration skills that you need will be taught next week. And do come to Game Jam. Do come to Week 5 Game Jam if you want to put your current Unity knowledge to test. It's going to be from 12 p.m. to 10 p.m. It's 10 hours. Okay, 12 p.m. to 10 p.m. on 14th September. The venue we will separately announce on our social media. So you should see the announcement post in these 2 days. We will try to get this out this weekend. Come over, free pizza. It's the only time you can get your tuition fee back from School of Computing. They sponsor us, okay? Don't tell them though, okay? Okay, they do know, but
Can you bring friends from outside?
you can bring friends from outside of GDG, but it's only open to NUS students.
Can we then if for example we can't make it like say can we like come a bit later?
Yes, but the group forming starts at 12:30. So if you are coming solo, you probably want to come early so that there will still be people that don't have groups. If you already have a group that you want, that you have friends around, then yes, you can come a bit later. The actual development should start around 1 and should end around 9:30. So technically speaking, it's a 8.5 hours game jam. Sounds good. Sounds good. Okay, cool. So if there are no questions, this is the end for today. Thank you for coming. If you have any questions, you can ask now, leave back, have a quick discussion. Haven't seen you all up until today. So if you have any random topics you want to talk to me about, that's fine as well. Game development, graphics, CS life in general, if you're a freshie. Yeah, that's all cool. So let me stop the recording here.